I know we're doing some of this, but still, it's always nice to have that. So one thing, I think I said this in class before, and I know it seems like a little thing, but you know, this doesn't make any sense. This makes complete sense. That little thing, I mean, it's just, you can make so many little mistakes if you put them in the wrong place. Okay. And you can alternate between the forms, between the prime forms and the operator forms, as you need to. Operator forms are really useful for elimination. And then the minute you've got the result, you want to maybe put that back in a prime form so it's more like what you're used to solve it. So here I've got, so here, you guys try this real quick. Number 4. See how far you get. I like it. It's non-homogeneous. It's always fantastic. So just make sure everybody's thinking the right way. This is an example problem where it really doesn't matter who you kill first because they're opposite signs. They both have relatively the same thing. The nice thing with this one is, yeah, you don't have to do any extra, you don't have to do both of them by something. This one I have to do this one by 3 and this one by d minus 2 so that they end up with the same opposite sign coefficients, right? So personally I would kill the y's first, but it doesn't matter. Questions? And that's if you're going to kill the y's. A little different when you kill the x's. If you kill the x's first, I'll catch up to you eventually. What does this mean? So the derivative of that is that. Yeah. And then negative 4 times this is 4. And what's nice is if you leave this in this form, you can actually see the auxiliary equation there. Right? Let's see what I get there. Negative 4. So this would be so the auxiliary equation, you're going to get m equals 5 and 1. And being really careful understanding this is x as a function of t. This gives you xc equals
C1 or e to the 5p plus C2
I like it. Now how are you going to get xp?
x equal a x
Yeah. No, so we go. So let's see.
but
So yeah, exactly good. So xp normally it would be a to the t, but
a x
well,
but a t.
at e to the t.
Oh, okay.
That's the sucky thing about this is remembering it's x and y as functions of t, and the x creeps in sometimes. And some of you guys did that. It's really easy to do that. A to the t. So then x prime. A to the t plus a to e to the t. I like it. And then you need x double prime. And again, if you wanted to, you can rewrite d squared x as x double prime, if you need to. Minus 6x prime plus 5x. So then you know where those go. Or you could just, instead of primes, you could just put dx Everybody cool with that so far?
How'd you get AT e to the t?
So it's a product rule, right? Derivative of t is 1. And the derivative of e to the t is e to the t. So each of these get a term. Because what does d mean? It's d by dt throughout this whole thing. So this is a product. Derivative of at is a times e to the t. Then at times, what's the derivative of e to the t? E to the t. Good old product rule. And then d squared would be a e to the t plus another a e to the t. You guys see that? Whoop. Plus a t e to the t. Now you just got to throw that stuff back in. D squared x is that bit minus 6 times that bit plus 5 times that bit equals that bit. Oh shit. What's time we got? All right. Let me stop here. What's more important than the specific parts of this problem is the process used. So why did I have to assume it was a t e to the t? Because of this, it already has e to the t. That makes the stupid thing 0. So assuming that's the answer can't be, it's not going to give me anywhere. It's going to give me 0, never this. So you can see why it makes sense that it would be this, because that does have parts that are just e to the t. Okay. So now if I throw all that in there, let's see. So d squared x is 2, not x, yeah, x. 2a e to the t plus at e to the t minus 6 dx, that'd be minus 6a e to the t minus 6at e to the t plus 5x, that'd be plus 5at e to the t e to the t, I love it, Jeff. At e to the t. And that's supposed to equal negative 4e t. So then I get, let's see. Yeah, so I just get negative 4a e to the t. And then all these, thankfully, cancel. Do you see that? It's beautiful. So negative 4e to the t equals negative 4e to the t, so a equals 1. So xp equals t e to the t. So x equals c1 e to the 5t plus c2 e to the t plus t e to the t. So then how do I get y easily?
Plug back in.
Which of the original ones will I use?
First one.
One with the derivative.
Yeah, the one that y has no derivatives on it. So I solve this for y easy. I just take dx minus 2x plus e to the t will equal y. Right? And I know what x is, so when I grade your stuff, if you would have solved for y first, your coefficients would have had an inverse relationship to what I would have got. I don't know if you guys see that. Here they're just C1 and C2. Y is going to have some multiple of those. It would have been the reverse of that if you would have found y first. And if you don't understand that, that's just, I'm just letting you know that. To watch out for
There is
that.
no like shortcut way, like you see how y is present and with the derivative of x.
Yeah, like I said.
You have to do it all over again, but
Yeah.
for the other than and then take your coefficients and compare them.
Yes, exactly. So you have to be ready for that possibility. So then y would equal, and the funny thing is, you know what dx is, and you know what a is. So you have dx staring you in the face. I don't know if you guys see that. So dx would be e to the t plus t e to the t. Well, you want the whole thing though, Jeff. All right, that's fair enough. So y would equal dx minus 2x plus e to the t. I just throw that in there. Y would equal 5c1 to the 5t plus c2 to the t. This is all derivative of x. Plus to the t plus t to the t minus twice all that stuff plus e to the t. And then you just have to combine all that stuff together. Now on balance, I'd much rather do that than try to do the whole thing again and then equate coefficients like that. Equate the c's and the c3s and the c4s. I like it, but like you said, you can't always do that. All right, so for Wednesday, I'm going to have all the answers for this. So I'll give that out towards the end of class. But I want to start off with, I want you to try some of these out. Obviously, homework is number one, but that Section 8 one should go pretty quickly, hopefully. Yes.
Will we have like the box transforms on the final?
Yes, that's numbers, both number 6s and number 7s.
I mean, will you give us like the chart?
Oh, yeah, definitely. I'm not going to make you memorize more than I made you memorize already. Does that make sense? Yeah, dude. We're on the first day of finals. Not 6, yeah, that's awesome. 6 a.m. No, not 6 a.m.
Is the test correction for 3 due Wednesday or Monday?
It's due the day of the next test, which is the final. Yeah. All right.
Test corrections.
Thank you.
Yeah, can I get it back? Just for Josh.
Questions?
Yeah, can I get it?
Yeah.
It already that. See?
Professor?
Yeah.
So, I have a lot of practice this way with this specific problem, but it just seems like always, like even on the homework and stuff, they always like, you know, the problems were always involved with the shortcut, and we never really learned the actual long way, like if nothing goes right, you know what I mean?
I don't know if you remember
Then you gotta equate the
very first example we did it both ways. Yeah.
So I guess my question is, let's say this doesn't work out and that y is not in one of the systemic equations. I would compare and contrast the x and the y's, and then like let's say if the x of t had like a sign, c1 sine of t, and then the y of t had a sign, you compare those two, right? Like let's say, because if you have a c1 for the x and like a c4 for the y, you compare those to see.
Well, what you do is you solve all the way for x, and then you solve again all the
For
way
y,
for y,
but you're
and then
gonna
you
get
plug them
complete-
back in and force them to actually make this work. Then
Oh, so you
you'll
plug
get
all the-
and then
and then
you're
you'll
basically going to end up
with
equating coefficients of the things that are like functions, right? So I mean that's
Yes, so you're
Yeah.
gonna have like C1 sine of t equals C4 yada yada.
2c4 sine
Two
t.
C- oh, right, and then
And
you'll figure out what
C,
C1.
C4 is 1/2 of C1. Yeah.
Yeah,
Exactly.
okay.
Exactly. Exactly. Cool. I'm pretty sure they an example. We did one together, but did they have? Where was this? Wait a minute. Let me think. 4/9, right? Yeah. I think that's the way they did the first couple, and then they said, "Oh yeah, guess what? You don't always have to do this shit." Yeah. See here.
Right. Okay, so
Yeah.
you'll find the relationship. You'll
Plug
them
that
up.
stuff in. Yeah. Yeah. Exactly.
Okay.
Yeah. So here's one example of what you're talking about with the C's. You get a relationship between several of them. Yeah. That one's a good one to look at. Example 2.
What page is that?
Because this one is one I'm talking about because it involves multiple derivatives. So I wouldn't necessarily want to solve for one and plug it back into the other one because then it involves
It just gets a lot of
integrating ugliness. So I it'd be a lot easier actually to do it the full blown way and equate coefficients. Equate
Yeah.
coefficients. Yeah.
But a lot of times I don't mind, like, the answers we get are e to the t or sine or cosine. Integrating those are kind of easy, you know what I mean? Even like double integration on like
Yeah.
sine or cosine, I'd take that all day.
Yeah.
Whatever, if it saves me work, it's when it gets like
It's just
complicated
also
stuff.
keeping the C1, C2, C3s moving with it correctly also. There's just more places to make mistakes.
Right, when you integrate
the
those
integration
C3s
itself shouldn't be difficult. It's just keeping things in the right place. I don't know if that makes sense. Keep making sure everything comes with you and you don't just...
Well, in a sense, when you integrate, you're creating a new seed. So then you have to accommodate for that too as well, right? Or do you just ignore that?
No.
new seed?
So
'Cause
what I'm talking, see,
it
that's
didn't
what I
start
mean.
from the bottom.
If this was dy or something, and you threw the x in there, you'd have to get that stuff over and then integrate.
Right.
Okay,
right.
so it wouldn't be creating new seeds. You would be carrying the old seeds with you.
Okay.
So that, because we're talking about how to avoid having to get C4 and C5 and then
Yeah.
so one
It
way,
just takes forever.
way, so that's why it's just really a question of preference, right? I mean, it's not that hard, but
No,
I just know from experience
The
that
hardest
that's,
part is just figuring out an operator to operate.
if there's a D here, I just know from experience that's where students could make easy mistakes. Is when they try to put it in and integrate, they make mistakes with their constants, always. So that's why I'm like, you always look for this, or you do it twice and then equate the constants.
Yeah.
But it works, dude. It'll work that way.
Plus, these are nice because you can check your answer in a way. In a sense.
Well, yeah, of course. If you have time, you can
Yeah.
get the full answer and then plug it in the other one that you used. Yeah, that you